Welcome to LearnWise Academy. Today we'll be looking at domain and range. This is a new subheading under functions. Okay. Now, what do we mean by domain and range? We're asked to find the domain and range of all these functions. So all these, these are different kind of functions. So we're asked to get their domain and their range. So first of all, what do we mean by the concept of domain and range? When we say domain and range, what do we mean? So for domain, we simply mean the inputs of the function. As for domain, we mean the inputs of the function. While for range, we mean the outputs of the function. That's the outputs, more like the outcomes you have when you impute your domain. So let me give you a concept of domain, like what I mean by domain, how you can imagine it. So domain is just like imagining you having an undestoned rice. So you having an undestoned rice that is made up of stones, made up of chaffs. So domain is more like the rice itself, while the chaff and the stones are your restriction. So those chaff and your stone are your restriction, and the domain itself is the rice. So now when you remove those restrictions, you see that the rice will be eatable. Like to be edible, it will be edible, to be good for eating. And when you then grind that rice, you have the stone, you will have a grinded rice, which is called the range. So these are what we have. This is what I can give you as a constant thing to think of when you're thinking about domain and range. Okay, we have some examples here. They said finding the domain and range of some of some functions explicitly. So we have example. Example number one says f of x is equal to what? 5x minus 3. F of x is equal to 5x minus 3. And number two says g of t is equal to square root of 4 minus 70. G of t is equal to square root of 4 minus 70. And number three says h of x is equal to minus 2x squared plus 12x plus 5. And the fourth one says g of x is equal to x plus 1 all over x minus 1. And number five said f of x is equal to x minus 4 all over x squared minus 2x minus 15. And number five says f of z is equal to absolute value of z minus 6, close absolute value minus 3. So how do we work with domain and range of this function? Now the first rule I'm going to give you is that for you to solve domain and range of any function, the first step to take is to dictate what kind of function is this. What kind of function is this? So let's look at this number one and know what it's saying. All right, for number one, we have f of x equal to 5x minus 3. F of x equal to 5x minus 3. And this number one is a linear function because it is of degree 1. There's an invisible one here. So we'll call this kind of function a linear function. So I remember I told you that domain and range, you work with domain and range depending on the kind of function you are working with. So this function, we know this function to be a linear function. So what does it imply? It implies that the domain, it implies there's a rule for all linear function. So the domain for all linear function, the rule for the domain of all linear functions, since they are linear, we can't make them undefined and they cannot be complex. It means that the domain is always ranging from where? Negative infinity down to what? Positive infinity. So which can also be called the whole real line. So what about the range? What about the range? The range, if I impute the whole real line into this particular function, my outcome will still be the whole real line. So this is the domain and the range for all linear functions. So what about number two? Number two says g of t equal to square root of 4 minus 70. First thing to do is to dictate what kind of function is this. This kind of function is called what? A radical function. A radical function. Now, since we know it's a radical function, what's the move? So we say solution. So how does radical function behave in terms of domain and range? You know it's a radical function because we have a square root. Now, since we have a square root, what do we mean by radical? Now this square root we have, we don't want it to go complex. Remember I told you that the restriction we are talking about are for our functions to go complex. We don't want it. It's a restriction. That means square root is more like a restriction. We are restricting the square root from going complex. And again, is when it's a fraction. We don't want the denominator to be 0, because if the denominator becomes 0, the function will be undefined. So g of t equal to square root of 4 minus 70. The square root there, we don't want it to go complex. What do we mean by complex? When we have something like square root of minus 1, which is equal to I. This is what we mean by complex. So we don't want to have square minus inside the square root. So what do we do in order to avoid this kind of situation? We say whatever that is in the square root must be greater than or equal to 0. So what is in the square root? 4 minus 70 must be greater than or equal to what? 0. Now since 4 minus 70 must be greater than or equal to 0, what do? The next move, remember, for all radical function, this is the way we work with it. We'll first of all say that whatever that is inside, let me call this star, whatever that is inside the square root must be greater than or equal to what? 0. That's the first step. And the second step is to solve for t using your inequalities q. So how do we solve for t using our inequalities q? Is to subtract 4 from both sides. So how do we subtract 4? So subtract 4 from both sides of the inequality, or you say from all sides of the inequality. So let's subtract 4. Why are we subtracting 4? Because 4 is positive. So I need to subtract 4. If 4 was negative, I will add 4 to both sides. But since 4 is positive, it means I will subtract 4 from both sides. So what's it going to be? We're going to have that's 4 minus 4 minus 70 greater than or equal to 0 minus 4. So 4 minus 4, that will give you 0. What do you have remaining? Minus 70 greater than or equal to 0 minus 4, that should give you minus 4. So what's the next move to take? Is to divide both sides by minus 7. Divide by minus 7. So minus 7 will choke out minus 7. T, because I divided by negative, I'll have t remaining here. But because I divided by negative, my sign will change from greater than to less than or equal to. Minus will cancel minus. What do I have remaining? 4 over 7. So this becomes my domain. But I always like writing my domain in terms of inequality notation. So let me write my domain in terms of inequality notation. So how do I do that? I will draw a number line system. I will call here my negative infinity and call here my positive infinity. I check the number I have here. The number I have there is 4 over 7. And then check, is it locked or is it open? It's locked because it's less than or equal to 4 over 7. So I will lock it at 4 over 7. So some persons might decide to test. You choose a number that is bigger than 4 over 7. You know, numbers from 4 over 7 to positivity, numbers at this range are numbers that are bigger than 4 over 7, while numbers at this range are numbers that are less than 4 over 7. Example of numbers I can meet here, I can meet 2, I can meet 4, I can meet 5, I can meet 6, and so on. Here I can meet minus 5, minus 6, minus 2, minus 3. All these numbers, they are numbers that are less than. These one are numbers that are bigger than 4 over 7. So I can decide to test, or I can decide to, go through a particular trick we do use from secondary school. So I can decide to test. How do you test? You pick a number that is bigger than 4 over 7. When you pick a number that is bigger than 4 over 7, you impute it into your function. If it gives you positive, it means that this side is positive. I can pick a number at this side, which is a negative number, and I impute it into my function. If my result is negative, it means all these sides are negative. But in order not to stress yourself, you check, where is my arrow facing? It's locked at 4 over 7, and this less than sign is facing this way. So it means it will go from 4 over 7 down to where the less than sign is facing, which is what? Down to negative infinity. So it means that my domain will be what? Locked. Remember, it's locked at 4 over 7, so I can use close bracket 4 over 7. Then it will go from 4 over 7 down to negative infinity. That means 4 over 7 down to negative infinity. So this becomes my domain. Now, how do I confirm my answer? Or how do I get my range? Okay, let me get my range. In getting my range, I confirm my answer. So what about the range? So the range here will be equal to what? Range is gotten by imputing your domain. So I can first of all impute 4 over 7 into this function. Since 4 over 7 is the first number I have, So I impute 4/7 into this function. What would I have? Let me do that here. This will be, as put it as t into this function. That will be 4 minus 7 bracket 4/7. I will have square root of 4 minus 7 will cancel 7. What do you have remaining? Minus 4. And this will be equal to square root of 4 minus 4. That will give you what? 0. And square root of 0 is equal to what? 0. So you see, I've gotten 0. That's the first result. When I impute the first interval, that's the first endpoint in the domain, it will give me 0. And it's locked at 4/7. So I'll also lock it at 0, comma. Now, negative infinity means large negative number, or any negative number you can think of. You can decide to think of 2. So that I mean minus 2. If I decide to pick minus 2 and then impute minus 2 into this function, how would it look like? To now be square root of, let's know our result, square root of 4 minus 7 bracket minus 2, and this will be equal to square root of 4 minus 7 times minus 2. That should give you plus 14. And when you do everything, you should have square root of 4 plus 14. That should give me what? 18. And square root of 18 should give me a positive number. So what is this saying? It implies that any negative number I pick from negative infinity and impute it into this function, that my result will still be a positive number. So it means that if I pick a negative number and impute into my function, my result will still be positive. So it means it will go from 0 down to positive infinity, because the result I'll be getting when I pick negative number, impute, their outcome will always be positive, and those positive number are in positive infinities. So that's why I have 0 comma positive infinity. So this becomes the range of this particular function. Okay, over to number 3. What do we have in number 3? Number 3 says that h of x is equal to what? Minus 2x squared plus 12x plus 5. So h of x equal to minus 2x squared plus 12x plus 5. So what kind of function is this? This function is called what? A polynomial function. A polynomial function. So how do we work with polynomial functions? How do we work with them? And the first thing to do in polynomial function, okay, it has a general rule. Since it doesn't have square roots and it's not a fraction, it means that there is no restriction in this particular function. We have other restrictions apart from square root and fraction. We also have a logarithm. When you have logarithm, you should be careful of some things. We also have a what's it called? Restrictions in absolute value, but that one is in terms of the range. Are you getting me? So now we have h of x is equal to minus 2x squared plus 12x plus 5. So what do we do for polynomial function? Now the domain for all polynomial function are always ranging from where? Negative infinity down to positive infinity, which can also be called the whole real line. This is the domain for all polynomial function. So what about the range? What about the range? So how do we work with the range for all polynomial function? We get the vertex of the function. We get the vertex. So what formula? We have a formula for getting vertex. So for what formula do we use in getting the vertex of a polynomial function? So the formula says x naught comma y naught equal to bracket minus b all over 2a. This for all polynomial function. This is the way we work with it. In order to get the range, we need to get the vertex. That means the turning point of that particular function. When we plot the graph, where at what point will the graph turn? Maybe it was going down and all of a sudden go up, or maybe it was going up all of a sudden go down. So at what point do we get that? So we have x naught comma y naught equal to bracket minus b all over 2a, comma, we're having a function of h. So this becomes h of minus b all over 2a. This is what we have. So how do we get this? This is our function. Our function is what? Minus 2x squared plus 12x plus 5. So let's call this our a, let's call this our b, let's call this our what? C. So since this is my a, this is my b, and this is my c. So what do? I need to get minus b all over 2a and h of minus b all over 2a. So it suggests that x naught comma y naught will be equal to bracket minus b. What's my b? 12, and 12 is positive. So but because the sign is carrying, the formula is carrying minus, I'll have minus what? 12 all over 2 2 times a. What's my a? My a is -2. So -2 times 2, that will give you what? -4. And I have comma h of, remember I said h of minus b all over 2a. What's minus b all over 2a? Is -12 over -4. So it's h of -12 all over -4. So what do I have? That x naught comma y naught is equal to, minus will cancel minus, 4 cancel 4, 1, 4 going to 12, that will give you what? 3, comma. So here will still be h of what now? Since these guys will still give me 3, so I'll have h of 3. This is what I have. Now, how do I get h of 3? Because I'm interested in the outcome. This is the x value in coordinate system. When x is 3, what will y be? So I'm interested in the y value. That is what I use in getting my range. So I'm interested in h of 3. So when we say h of 3, what do we mean? So h of 3, let me do it at this side. H of 3 simply means impute 3 anywhere you are seeing x in your function. So what would I have? I'll have -2 bracket 3 all squared plus 12 bracket 3 plus 5. So this will give me what? -2, 3 squared, that will give me 9, plus 12 times 3, that's 12, 12, that will give you 24. Another 12, that will give you what? 36. Then plus 5. So what else do we have? Okay, -2 times 9, that will give me what? -18 plus 36 plus 5. If I do everything correctly, I should have what? 23. -18 plus 36, then you have plus 5. So everything should give me 23. So it means that h of 3 is equal to 23. I will now place it here. That x naught comma y naught is equal to bracket 3 comma 23. So now I will now look up this. Remember I said I'm interested in the y value, which is 23. So I will now check. In order for me to now generalize my range, what will now be my range? I will check my function. Is it a negative quadratic graph or is it a positive quadratic graph? My function is a negative quadratic graph. Why? Because the leading coefficient of x squared, that's the coefficient of x squared, is negative. Whenever the coefficient of x squared is negative, it means it's a what? A negative polynomial, or the leading coefficient of the highest degree. If it's negative, it means that's a negative polynomial. If it's positive, it means that's a positive polynomial. So this one is negative. There's negative sign here, so it means it's what? A negative polynomial function. So since it's negative, it means that my range will go from where? Negative infinity up and get to where? This my y value here, that is what? 23. And you close it, it will not exceed 23. So this becomes my range. But had it been this was a positive quadratic graph, I cannot write from positive infinity to 23. Rather, I would say from 23, that's close bracket, from 23 down to positive infinity. That's what I would have said. And remember, this is called a closed bracket. It shows that it doesn't exceed 23. It stops at 23. So this is what we have as my range. So my domain will be all real numbers for polynomial function, and my range will always use vertex to get the range of polynomial function. So remember that I said the first thing to do is what kind of function are you working with? Then you now know what to do. So these are for polynomial function. This is the way we work for it. So what about number 4? Number 4, solution for number 4. Number 4 says that g of x is equal to x plus 1 all over x minus 1. So we have g of x equal to x plus 1 all over x minus 1. What do we do? This kind of function is called what? A rational function. It's called a rational function. So how do we work with rational functions? How do we work with it? For rational functions, they are more like fractions. We don't want the denominator to be 0. We don't want the denominator to be what? 0. So what do we do? First thing to do is to say that our denominator cannot be equal to 0. Our denominator d cannot be equal to 0. So what's my denominator? My denominator is what? X minus 1. It cannot be equal to 0. So what's the first move to take? We are looking for the domain now. The next move to take is to now make x subject. If I cross -1 to this side, it becomes that x cannot be equal to what? 1. Now, since x cannot be equal to 1, what does my domain say? My domain says that x can be every other real number, any number you can think of, but excluding the set of what? 1. Excluding 1. That means x can be any other thing excluding 1. Why do I say so? Because if I impute any other number as x here, the function will still be defined. But immediately I impute 1, the function will be undefined. Let's try. If you impute 1, what would you have? As x, you have 1 plus 1 all over 1 minus 1. And 1 plus 1, that will give you what? 2 all over 1 minus 1, 0. This kind of function is what? Undefined. Is undefined. So this kind of function is undefined. Anything divided by 0 is undefined. So that's why we say that x can be all real numbers but except 1. So what about the range? The range for rational functions. What's the range? The range, if I put all real numbers except 1 into my function g of x, what will be my result? The outcome I will be having is still real numbers. So this becomes my range. Why did I say so? Pick an example of real number here. Domain range is gotten from imputing the domain into the function, right? So if I pick 2 from here now and impute here, 2 is a real number. I'll pick 2 and impute here. You see, I'll have 2 plus 1, that is 3, all over 2 minus 1, that is 1. So it becomes 3 over 1, that is 3. And 3 is also a real number. So that's what we mean by the range will still be what? All real numbers. So lastly, let's look at number 5. Lastly, number 5 says that f of z is equal to absolute value of z minus 6 close absolute value minus 3. So we have solution. So how do we work with absolute value functions? How do we work with absolute value functions? So the first thing to do in absolute value function is to note that the domain for all absolute value function are always from negative infinity to what? Positive infinity. There is nothing we can do for an absolute value to be undefined, and there is nothing we can do for an absolute value to be complex. So it means that the domain is always from negative infinity to positive infinity, which can also be called the whole real line. So what about the range? What about the range? How do we get the range? Now, if look at the way we get the range of absolute value, there's a procedure we use in getting it, more like a trick. Now we say all absolute value function. Let me say absolute value of, let me take an instance now. Absolute value of dots. Dot means anything. Absolute value of dots must be greater than or equal to 0. This is the rule. Absolute value of anything must be greater than or equal to what? 0. So let me pick an example of the one I have. The one I have shifted 3 times negative. The absolute value shifted 3 times negative. So how do I work with this? I'll first of all say that the absolute value of what I have, which is z minus 6, first, remember I said the absolute value must be greater than or equal to 0, because absolute value cannot produce a negative result. So anything you put inside the absolute value should come out positive, and positive means greater than or equal to what? 0, because anything that is less than 0 is already negative. So first of all, say absolute value of z minus 6 must be greater than or equal to 0. According to this rule, must be greater than or equal to 0. But I still have minus 3, shifted 3 times negative. So I will still put back my what? Minus 3. So what does it mean? It means that this implies I'm going to have that absolute value of z minus 6 is greater than or equal to what? Minus 3. So these have already given me the outcome, that the outcome of this absolute value must be greater than or equal to what? Minus 3. So what does it suggest? It means that I can play this on my number line. My number line is negative infinity and positive infinity, and we have what? Minus 3. So I will check, where is my arrow facing? You know it's locked at minus 3 because it's greater than or equal to. So I will lock it at minus 3. So the simple trick we usually use, instead of testing, you can check where your arrow is facing. My arrow is facing this way. So it means it will go from minus 3 down to positive infinity. So it means that my range will be what? My range will be closed at minus 3. Look at my range is from minus 3 to positive infinity. So my range will be closed. So I'll use a closed bracket at minus 3, but will be open at positive infinity because we can't close on infinity. So this becomes the range of this particular function. Now let's go back to our question and see what we have done. we have been able to get the domain of the first one, domain of the second one, domain of the third one, domain of the fourth one, and domain. Okay, I miscounted this. This is 5, and this should be 6. That is okay. This should be 6. This should be 6. So domain of the fourth one and domain of the sixth one. So help do the domain of the fifth one. Try out the domain of the fifth one, and then post your answer to the number at the comment section for corrections. As if you solve and you feel like you want to know whether it's correct or not, you can post your answer at the comment section, then we can discuss about it. So this is how we solve the domain and range of some functions explicitly. This is how we work with them. So thank you very much for watching. Kindly like, subscribe, and hit the notification bell to get our video when we upload them. Thank you very much. See you in the next class.